Hey Algebra 2, I wanted to do a quick example from 6.3 or two examples of summing radical expressions and to kind of further emphasize this issue of the domain of the expression and whether we need to worry about absolute value or not. Okay, let's look at two quick examples here. Let's get some pens, and first thing, the instruction you'll often see from the book or on a test is simplify, assume that each radical represents a real number. Okay, first, a little bit of analysis. Can you see that this is square root of y? So that's square root of y. And so if that's square root of y, that instantly means that y has to be greater than or equal to 0. Because if y were negative, then square root of 45y would be square root of a negative number, and that would not be real. So because of the instructions where we assume that everything is a real number, we can conclude that the domain of y is all non-negative numbers. It's either positive or 0. Okay. So with that in mind, let's do the analysis. So we've got y squared square root of, now 45. 45 is 9 times 5, or 3 squared times 5, times y, plus 2y square root of, now 125 is 5 cubed, but I can put 5 squared times 5 times y squared times y. And I'm going to adjust my radical there a little bit to lengthen it and include this. And we were not able to add the terms together at the beginning, and we still can't add them because the variable terms don't look the same yet. At least it's not clear. And I can see that a 3 is going to come out of this. Square root of 3 squared means a 3 comes out. And actually, that's it. I've got y squared and then square root of 5y. Now on the next one, I can see a 5 comes out because there's a 5 squared under the radical. When the 5 comes out, it'll multiply by the 2, so I'll get 10. And I've got a y out here, and I can see that another y, factor of y, is going to come out. Square root of y squared, a factor of y will come out, and I'll have y squared. What am I left with on the inside? 5y. So look at our variables. The variable part of our terms are y squared, square root of 5y, y squared, square root of 5y. So since the variable parts are the same, we can combine like terms. And we get 3 plus 10 is 13, y squared, square root of 5y. Done. One more example. This one's a little bit of a nastier example, it appears, to start. And again, the same analysis is going to show that this term tells us that x needs to be greater than or equal to 0. There's no way, actually the last term as well. Otherwise, the second term and the last term would be non-real. So I don't need to worry about absolute value. All right, let's do it. I have 4th root of, now I want powers of 4. Well, 64 is 2 to the 6th power, so that's 2 to the 4th power times 2 squared. And then x to the 18th. I want a multiple of 4, so x to the 16th times x squared. And I'll lengthen that radical out a bit. Plus x squared. Okay, now this first one was a 4th root. This is a square root. So now underneath this, I want powers of 2. So this will be 3 squared times 2. And x to the 4th times x. And I'll put a square root over all that. Okay, and I like the x to the 4th there because 4 is a multiple of 2. On the last one, 3x. Now I have a 6th root of. Now underneath this radical, we'll have, well, let's see. This is 2 to the 3rd, and 6, a multiple of 6 that's less than 21 is 18. So this would be x to the 18th times x cubed. I'll put that all over that. Let's keep going. Let's pull out everything that can come out. A 2 is going to come out of here. The x to the 16th to the fourth root of x to the 16th. This 16 will divide by 4. So I'll get x to the 4th to come out. And that's it. What I'm left with is 4th root of 2 squared x squared plus x squared times, now what comes out of here? This is square root. So a 3 comes out. Probably should have erased that. Say a 3 comes out. I've got an x squared. And I get another x squared out of here. And I end up with square root of 2x. Okay, minus 3x. And what else comes out? 18 divided by 6 is 3, so an x cubed comes out. That power of 18 gets divided by 6. And on the inside, actually on the inside, I'm left with, so this is a 6th root of 2 cubed times x to the 3rd. Okay, now, they don't look the same yet, but they are the same. They are like terms. And we need to remember that the nth root of the mth root of x is equal to the n times mth root of x. So for example, the square root of the 3rd root of x is equal to the 6th root of x. And what we have here is 2x to the 4th. And the 4th root is the square root of the square root of 2 squared x squared. Plus, well, this one's already square root, and there's 2 is a prime number, so we are as simplified as possible. And 3x to the 4th. And 6 is, now notice I have powers of 3 down here, so it'd be really nice if I put the square root of the cube root of 2 cubed x cubed. Now notice this is cube root, and there's like this is square root, so that's a 2nd root. And just to make my writing very clear, I'll space that out just a little bit, put a little notch there. I just want to really clarify that this is a 2nd root of a 3rd root of 2 cubed times x cubed. Let's keep going. 2x to the 4th square root of, I'll put it over to the side a little bit so the power of 4 doesn't look like it's the index of the radical. Square root of 2 squared x squared is 2 times x. Now I don't need to worry about absolute value because we've already analyzed from the beginning that x cannot be negative. But I would have to worry about absolute value there. Okay, I would have 3x to the 4th square root of 2x minus 3x to the 4th square root of, now cube root of 2 cubed x cubed is 2x. Now even if x could be negative there, I wouldn't have to worry about absolute value when I did that cube root, but then I'd be left with x. If x were negative, and if x were allowed to be negative, then I'd be cubing that, and that's negative. I'd be taking the cube root of that, which is negative, and then I would be trying to take the square root of that, and which should not be real. So another reason why we know x cannot be negative. And you will see I have the same variable part to all these. So I have 2 plus 3 minus 3 is 2. So I have 2x to the 4th square root of 2x. Because I just added the coefficients. 2 plus 3 minus 3. And I am done. That is all there is to it. Okay, I will see you in class.